Let's do this problem right here. The question is asking find eigenvalues related to the eigenvector 0, 1, 1, 1. So let's see how we can do this. In this case, we can use the formula that's AV is equal to lambda V, because we have A here and V is provided, so we can find the lambda using these things. Then let's copy the A down. So it's 2, 2 minus 2, and the second one is 2, 4, 0, and the third one is minus 2, 0, 4. And now I have to multiply this one with the vector that's provided, that's 0, 1, 1, 0, 1, 1, and the other side we have lambda times this vector, so 0, 1, 1 multiply with lambda. And let's do the matrix multiplication. This is a 3 by 3 matrix and this is a 3 by 1 matrix, so when we multiply we have to get 3 by 1 matrix. So let's do the multiplication. The first one is first row, first column, so it's going to be 2 by 0 is going to be 0, and 2 times 1 is going to be 2, minus 2 times 1 is going to be minus 2, so if you add them together, 2 plus minus 2 is going to become 0, so we can put the 0 on the first one. And the second one is going to be 2 times 0 is going to be 0, 4 times 1 is going to be 4, 0 times 1 is going to be 0, so it's going to be 4. And the third column is, the third row is going to be minus 2 times 0 is going to be 0, 0 times 1 is going to be 0, 4 times 1 is going to be 4. So this is 4. And let's do the multiplication in the other side. It's going to be lambda times 0 is going to be 0, and lambda times 1 is going to be lambda, and the other lambda times 1 is going to be lambda. So therefore we can say lambda is equal to 4. So this is the answer for the first question. And the second question is asking if 6 is the one of the 3 eigenvalues of A, find the other one. So let's see. So what we can do is, so in this case we have to know one more thing. The addition of eigenvalues should be equal, addition of eigenvalues is equal to the trace of this matrix. So if I add lambda 1 plus lambda 2, lambda 3, that should give us 2 plus 4 plus 4. So in this case we know lambda 1 we found out already is 4, and lambda 2 is provided, that's 6 in the question, 6 in the question, and lambda 3 is the question. That's what we have to find. And 2 plus 4 is going to be 10, and if you add them together this is also 10. Therefore lambda 3 is going to be equal to 10 minus 10. Therefore lambda 3 is equal to 0. Then the third question is asking if is A invertible. The answer is no, because if we have a lambda 0, it means the determinant of this matrix is going to be the multiplication of these eigenvalues. If you multiply these eigenvalues, that will give you the determinant. So let's multiply and see what we get. Determinant of A. So if we multiply this 4 times 6 times 0, this is giving us 0. So if we have a determinant with 0, that means that's not invertible. So therefore we can say this is the answer of the question is no. Therefore not invertible. And the other question is asking determine if A is diagonalizable. So to determine whether something is diagonalizable, we have to look at the algebraic multiplication and the geometric multiplication. In this case we have lambda is equal to 1 and lambda is equal to 4. Lambda is equal to 1 and lambda is equal to 4. Lambda is equal to 1 is written twice, therefore the algebraic multiplication is 2. And lambda is equal to 4 is written only once, so algebraic multiplication is 1. And also we have to know one more thing, that's A n by n matrix, the geometric multiplication is always lesser than or equal to algebraic multiplication. In this case we have lambda 4 has algebraic multiplication 1, therefore the geometric multiplication is exactly 1 because it cannot be equal to 0, therefore this is 1. But for the lambda is equal to 1 we have algebraic multiplication 2, but the geometric multiplication there are 2 possibilities. It can be 1, it can be 2, we don't know, therefore we have to check it. To check this one, what I have to do, I have to do the null space. Null space is what A minus lambda I set this one into capital 0, which means I take this matrix A, so it's going to be 2, 2 minus 2, oh no, I'm copying, this is the matrix, right? Wait a minute. So this is 110, 110, then 0, 1, 1, and 0, 0, 4. Now this is going to be lambda. I mean, when you multiply lambda by identity, it's going to be the diagonal, just going to be the diagonal. So when you subtract, you only subtract the diagonal. Diagonal is this matrix. So it's going to be 1 minus lambda, 1, 0, 0, 1 minus lambda, 1, and the last one is going to be 0, 0, 4 minus lambda. And from this one, we can find the geometric and algebraic multiplication, and other side we have to have 0 because this is a null space. And let's subtract these values and see what I get. So we are taking lambda is equal to 1, so this is going to be 0, this is also going to be 0, and then we have 3 right here. So let's see. So 1, 0, 1, 0, 0, 0, 1, and at the end we have 0, 0, 3, and we can eliminate the last one by multiplying the second equation by -3 and adding to the third equation. So let's do it here. 0, 1, 0, 0, 0, 1, minus 3 R2 plus R3 is going to give us 0, 0 row. And the other sides also, all of them are 0. And from this one we know that we have only one free variable. Therefore the dimension is equal to 1. The dimension is going to be equal to the geometric multiplication. If we have a dimension 1, the geometric multiplication is also 1. Geometric multiplication also 1. So we have algebraic multiplication 2, geometric multiplication 1. Therefore we have two different, it should be same in order to be diagonalizable, but in this case we have two different values. This is 2, this is 1. Therefore this is not diagonalizable. So that's the answer for the 5th question. And 6th question is asking, let A be a 3 by 3 matrix with the eigenvalues 2, 3, 1. Find trace of A inverse. We know that trace of A is addition of this diagonal. So what happened to the A inverse? And also we know that trace of A is addition of these eigenvalues. Both of them give the same answer. And in this case, they have given the eigenvalues, but they are asking for the trace of A inverse. So we have to know one more thing, that one of the property of eigenvalues is that addition of lambda inverse will give you the trace of A inverse. So in this case, what I have to do, I have to take the lambda inverse and add them together. So if I add them together, I will get trace of A inverse. So therefore we can say trace of A inverse is equal to 1 over 2 plus 1 over 3 plus 1 over 1. And if I take the common denominator of this one, this is going to be 6. And if I take the 6, this is going to be 3, and this is going to be 2, and on the other side we are going to have 6. And if we add them together, 5 plus 6 is going to be 11. 11 over 6 is the final answer. And that's how it's done. I hope you guys like this video. See you next time.